Hello, Pine Hollow pilots. This is Mr. Osterstrom, also known as Mr. O. I'm one of three science teachers at Pine Hollow. I will be narrating this set of footnotes on standard 6.E.1.1, which is technical terms for predictable patterns caused by the sun, moon, and earth. Keep in mind with footnotes you have some valuable tools. The first of which is the power to pause. As you're taking notes from these slides, the information on the slides is what you need to know. So pause the video, write down your notes, and then hit play to move on. You also have the ability to rewind. So sometimes you're in class and you didn't get that part of the notes or you didn't hear what something was said. You're able to rewind the video. No one knows. You can rewind as much as you like until you understand and get all the stuff you need down. The third of which is the most valuable tool. There's going to be a point where some things come up that are confusing to you, are unclear to you, you just don't get it. Write that question down. The most valuable thing you can do with notes is not just simply writing the notes down, but it's discussing the things that make no sense to you. Those rich discussions will help build a better understanding of what we're covering if you ask those questions. Remember, your teacher will meet with you after these notes and we'll talk about this content being presented. So ask those questions. It will help you and everyone else in class. Last but not least, you are able to use this video anytime you like. So when assignments are based on this content, you're able to refer back to this video and use it however you see fit. There are two different types of note collection options. First of which is a Google Doc that will be in your Google Classroom. It will match the standard number that we're covering. That handout is the exact slides in order of the way I'm discussing them to you. If you click on that, it makes a copy for you. You can type in your notes as you go. Also has some illustrations in there for you. Or you can go old school. You grab a piece of paper and you write the notes down as you go. I do believe that number one is more valuable for keeping you organized, keeping things neat and helpful to you as you go, but either way you choose is fine, but you must collect the notes in one way or another. First, let's cover what is a predictable pattern. You might reply back to that question as it's a pattern that's predictable. But by using the words that to define the word that I'm asking doesn't show mastery of content. Scientifically, a cycle of events that occur that we are able to time throughout the day, month, or year is a predictable pattern. If you recall in the ecosystem footnotes that we just had, we talked about the water cycle, the nitrogen cycle. They're also predictable. These predictable patterns are slightly different because we'll use days, months, year, or years like in eclipses to time them, unlike the water cycle, which isn't done in the same fashion. There are three objects that control the predictable patterns that we'll cover in sixth grade. These three objects are the sun, the moon, and the earth. There are two factors of the sun, moon, and earth that control the patterns. These two factors will be relative motion and relative position. Now, relative position actually will be discussed also with you in social studies later this year. Relative motion means how something is moving, and relative position is where something is. So these two factors together will help create patterns that we experience, and we'll talk about how they factor in different patterns. There are two key words that you have to understand before we get into the particular patterns. The word rotation and revolution are often misunderstood by students, and this misunderstanding will lead to problems when talking about what causes one pattern in comparison to a different pattern. The first one is rotation. It's one thing spinning, where if I ask you to stand up and spin around in a circle, you are rotating. Your bike wheels rotate. However, revolution is one thing going around something else. So if I ask you to stand up and walk around your chair, you are revolving around the chair. Likewise, all the planets in the solar system revolve around the sun. Now, the only thing that does get confusing is often things in our solar system rotate and revolve at the same time, meaning they're rotating while they're revolving, just like Earth rotates while we revolve around the sun. But we'll get more into that. But you have to understand rotation, one thing spinning, revolution, one thing going around something else. Now, the first of the 5 patterns that we'll talk about in sixth grade is the easiest one, day and night. This is simply caused by the Earth rotating on its axis. Now, the axis is tilted, which is more important in seasons, but because the Earth rotates, and it rotates one complete spin every 24 hours, we have day and night once a day, okay? At any one point, half the Earth is lit and half the Earth is dark. So if I have this illustration here, I know it's bad because the sun would be much bigger than the Earth if it was legit. But the half of the Earth that's facing the sun, if you're on that part of the globe, you're experiencing day. If you're on the half of the globe that's facing away from the sun, you're experiencing night. But as the Earth rotates and your position comes into the sun, you come into day, and vice versa. And every day that happens. There is one misconception that I often hear is that people think that the moon only comes up at night. This is not true. You might have seen the moon up during the daytime, but often the moon out during the day, you don't see it because the sun rays block it. But don't have the misconception that the moon only comes up at night. Now, the next predictable patterns is seasons. Now, seasons, unlike day and night is based on rotation of the Earth. That's it. Seasons have a little bit more complicated here. So it's based on revolution of the Earth around the sun on its tilted axis. Those things are all very important. That Earth revolves around the sun, and where it is at any given time during the year gives you different times. We have seasons. The tilt causes different seasons. If the Earth was not tilted, the seasons would be completely different. But not just the revolution and the tilt. As the Earth goes around the sun, the length of daylight and the directness and intensity of the sunlight changes throughout the year. Let me try to rephrase this, make this simpler. If you're in North Carolina in the summertime, the days are longer. It's sunny when you wake up. It's sunny when you go to bed. The directness intensity of the sunlight is far hotter here during the summer. But if you compare that to the way it is in winter, it's dark when you wake up. It's dark when you go to bed. The heat from the sun and the intensity of the sun, it's far cooler. So you can tell that where the Earth is in its rotation will change how much sun we're getting. It will change the directness and intensity of that sun, and in turn, it changes seasons. Now, the tilt of the Earth's axis also results in something else. It reverses the seasons that are being experienced in the northern and southern hemisphere. So, in Raleigh in July, we have summer. But if you were in Australia during July, you'd be experiencing winter, and vice versa. In December, in Raleigh, we experience winter. However, if you were in Australia during December, you'd be experiencing summer. So because they're on different hemispheres, it flips the seasons because of the tilt. And it also depends on position where you are on Earth. Like if you're near the North Pole or the South Pole or near the equator, there's far fewer seasons than if you are in North Carolina where we experience like 4 seasons. We'll talk more about that in class. So here's an illustration of how the Earth goes around the sun and how different seasons happen. And you can tell if you're tilted towards it, you have the warmer months, and if you're tilted away, you have the colder months. There's a misconception that we actually get closer to the sun during the summertime and further away from the sun in the wintertime. In actuality, the Earth is the furthest away from the sun in July, and it's the closest to the sun in January. So it shows you that it's really the tilt and revolution. It's not that we get closer or further away from the sun. The third predictable pattern is moon phases. This is something that should have been covered in elementary school. Our moon revolves around Earth. So moon phases is based on revolution of the moon around the Earth. And we both revolve around the sun together. Now, some people have the misconception the moon changes shapes. It does not. It appears in different phases because of where you are on the Earth and the angle of the sun bouncing off of the moon, and what you see is the moon phase. But it does happen in a regular cycle about every month. It's actually less than a month because in some far weird chances, we sometimes have 2 full moons in a month. However, it repeats and it's predictable and it's timed because if you look at a calendar, you can tell me when the next full moon is going to happen. And this is just a fun little factoid, is that the rotational period of the moon is the same as its period of revolution around the Earth, meaning those 2 numbers are the same. So when you're on Earth, you only get to see the same side of the moon always. The only way you can see the backside of the moon from Earth would be through a satellite image, or if you left Earth and saw it from outer space. Here's an image that you've probably seen before. Obviously the sun, obviously not the right size. But where the moon is in position, we talk about relative position. So if the moon is between the sun and the Earth, we see a new moon. But if the moon is on the opposite side of the sun, you see a full moon. And that's based on relative position and motion as it moves around. So you can see how those 2 factors play its part. The next is tides. Please do not confuse tides with waves. Waves are created by weather systems. Tides are created by the gravitational pull of the moon and the sun along with the Earth's rotation. Now, the moon has a far larger factor in this than the sun because the moon is significantly closer to the Earth. But Earth's rotating and the moon's gravitational pull is the reason of tides. Now, the forces from the moon and the sun can be in alignment or in opposition to one another. If they're in alignment, you experience high tides, and if you're in opposition, you experience low tides. And I'll explain that more in class and maybe with the image that you're about to see. And tides occur about 20, they occur every day, but in general, you usually have too low and too high every day. So you can see that it would take about 6 hours for a rise and fall of each tide. Now, some places on Earth only experience 2 tides a day, but tides happen every day. And if you ever go to the beach or if you Google tide times, you can see any coastal city will know exactly to the minute when the next high tide or when the next low tide will happen because it's a predictable pattern. Now, using this image, if you put yourself where that arrow is, if you're on Earth where that arrow is and you're in alignment with the moon, you'd be experiencing high tide because the moon will bulge the water towards it. But if you're not where that arrow is, say you're at like 12 o'clock on the clock, that's where low tide is because you're not in alignment. You're actually in opposition of where the moon is. And as the Earth rotates, the place where the high tide rotates with it. And remember, we rotate once every day, so the tide changes daily. The last is eclipses, by far the coolest one to experience. This is the alignment of the sun, moon, and earth, and they can produce shadows on either the sun or the moon, which is known as an eclipse. There's actually 2 types of eclipses. The 2 types are lunar and solar. Luna means moon, and sola means sun. So if you understand what those words mean, if the moon is shadowed, it's known as a lunar eclipse, which we just had one in Raleigh just about a month ago. And if the sun is shadowed, it's known as a solar eclipse, which we've had a couple of years ago here in Raleigh. Lunar eclipses happen far more often than solar eclipses. Here's the image of them. Lunar eclipse, not as cool. Solar eclipse, make sure you're wearing those glasses. We're actually going to experience the next total solar eclipse in Raleigh in the next couple of years. But just because of the fact that we are able to predict these eclipses to the exact day, time, and location where they'll happen proves why they're predictable. And we'll discuss that more in depth when we get back together. Now, keep in mind, have any questions arose during this set of notes, have them written down. Also, make sure you've written these notes down so you can use them as reference when we do different activities using this content. I hope all is well. Look forward to seeing you in class soon.